Good morning. We are Team, and this is our Vortex tube. My name is Christopher Baldwin.
And I'm Peter Dolce, and today we are talking about Vortex tubes.
A Vortex tube is a device that converts a high-pressure gas inlet into two separate streams, a hot and a cold stream. The Vortex tube uses a swirling effect to separate the single inlet into two separate outlet streams.
Vortex tubes use principles of thermodynamics and heat transfer to convert the air into two streams. The air swirls around the outside and is at a high pressure, some escapes, and the rest is sent into the center at low pressure, which is exhausted as the cold stream.
Some of the design parameters we considered were tube size, inlet size and location, control valve shape, nozzle size, and materials. The tube length is 10 times the diameter of the tube, while the cold flow nozzle is half the diameter of the PVC tube. The optimal cone angle is 50 degrees.
Our device was constructed from PVC tubing using a wide variety of fabrication techniques. The cone valve and cold flow nozzle were printed using a 3D printer, while the holes were cut with a drill press. All the pieces were then epoxied together.
This is a picture of our final design, with the cold end on the left and the hot end on the right. We have placed insulation around the tube to reduce heat loss to the surrounding air.
This is a view of the inlet nozzle on the top and the cold flow nozzle at the end.
This is the hot outlet with an adjustable valve to control the airflow out of the tube.
We had a total cost of $10.53. Most of our design costs came from the pressurized air nozzle and mounting, wood mounting board, PVC tube, and epoxy. The 3D printed parts were actually quite cheap, only costing about 50 cents a piece.
We achieved a minimum cold temperature of 0 degrees Celsius and a maximum hot temperature of 28 degrees Celsius.
We recommend a design which maximizes the air swirl effect to achieve a maximum temperature difference.
Thank you for listening.